Good morning students. Now we are going to see the lesson Nature of Physical World and Measurement. You know very well, physics being a fundamental science has played vital role in the development of all other sciences. We will see one by one. Physics in relation to chemistry. You know that the structure of atom, you are studying in structure of atom, radioactivity and X-ray diffraction. These all you are using in chemistry also to arrange the elements in the periodic table. And you know very well physical chemistry, quantum chemistry, that is also play a role, vital role, important role here. Okay, now the next one, physics in relation to biology. You know very well biological studies are impossible without a microscope designed using physics principle. You know this is a electron diagram for picture for the electron microscope. This electron microscope why you are using, this is used to study the structure of cell, for that you are using in biology side. And X-ray diffraction also used here, and this is a radioactivity. The radioisotopes are used in radiotherapy for cure which one? Cure the diseases, cancer. For that many diseases you are using this radioisotopes. The next one, physics relation to mathematics. Physics is a quantitative science. It is closely related to maths, is a tool for its development. The next one, physics in relation to geology. You know very well how it is. The diffraction techniques that help to study the crystal structure of various rocks. Okay, and the radioactivity, that process is used here to estimate the age of the rocks and estimate the age of the earth. For that you are using in the geology side. Then the next one is physics in relation to astronomy. How it is useful in the astronomy side? The astronomical telescopes are used to study the motion of the planets and the heavenly bodies also, and it observes this is a radioisotopes. This radioisotopes, it observes the distance points of the universe. Then physics is used in relation to oceanography to understand the physical and chemical properties. For that you are using, and it is used to measure the value of which one? That measure the value of speed, current speed. You are measuring the value of current speed, temperature and the chemical components here, all you are measuring here. So that is also related to which one? Physics is in relation to oceanography. And the next one, physics in relation to psychology. There also you are using the movements of neurotransmitter are governed by the physical properties of diffusion and molecular motion. And you know this is a brain. You know that the functioning of our brain also related to underlying dualism. Okay, so the physics more fields we are using. The nature teaches true science with physics as an efficient tool. Okay, now the first basic here in this side is measurement. You know what is measurement? The comparison of any physical quantity with its standard unit, that is called measurement. You are comparing the physical quantity with any standard unit, that is called measurement. What is meant by physical quantities? Quantities that can be measured in terms of which the law of physics are described, that is physical quantity. You know that two types of physical quantities are there. One is a fundamental quantity, the another one is a derived quantity. What is the definition of fundamental quantity? The quantities which do not depend upon any other quantities. So it won't depend upon any other physical quantity, means that is called fundamental quantities. Then what is meant by derived quantities? you are deriving from the fundamental quantity means that is called derived quantities. Now we will see one by one fundamental quantities and derived quantities. The first one is fundamental quantities. What is fundamental quantities? The quantities does not depend upon any other quantities I told. Example, length, mass, time, electric current, temperature, luminous intensity and amount of substance. These 7 quantities are called fundamental quantities. This is an example for fundamental quantities. So totally 7 fundamental quantities are there. Now the next one, what is mean by derived quantities? I told you are deriving from the fundamental quantities, that is called derived quantities. You see a few example I gave here: area, volume, velocity, force, pressure, speed, work done, like this. What is the area? How you will calculate any area of an object? You will calculate length multiplied by length, that gives the value of area. Length is measured in terms of meter. Again the length or breadth is measured in terms of meter. Meter into meter is equal to meter square. This meter is a fundamental quantity only. So you are deriving from the fundamental quantities means that is called derived unit. Now you see the volume. Volume is what? Length multiplied by height multiplied by breadth. So this length, that is volume. It is a fundamental quantity. So you are deriving from the fundamental. So this is called volume, is a derived quantity. Like the same way velocity. Velocity means what? Displacement divided by time. Displacement is length. Length is a fundamental quantity. Time is a fundamental quantity. So this is a derived quantity. Velocity is a derived quantity. Same way whatever here you are all deriving from the fundamental quantity. So that is the example for derived quantity. Then what is mean by derived quantity? You are deriving from the fundamental quantities means that is called derived quantities. Now the next one is, what is mean by unit? What is the definition of unit here? A unit is a standard quantity. A unit is a standard quantity with which the unknown quantities are compared. Units are two types here. One is a fundamental units, another one is a derived unit. The unit used for the fundamental quantities, for length which one you are using, for current which one you are using, the fundamental units, that is fundamental quantities, the unit measured used for the fundamental quantities are called fundamental units. So automatically the unit used for the derived quantities called derived units. Okay, now the next one, different types of measurement systems. What are the systems we are using here? A complete system set of units which is used to measure all the kind of fundamental and the derived quantities. That is a system. Totally how many systems are you here? Common systems are in this side. Totally 3 common systems are here. The first one is a FBS system. FBS system means what? FBS. F, the length is measured in foot. Mass is measured by pound. And time is measured by second. So the first letter I am taking F. Here it is P and this side S. So it is FBS system. Second one you see CGS system. The length is measured by centimeter, mass by gram and time by second. So this is CGS system. Third one is MKS system. MKS system means what? Length is measured by meter, mass is measured by kilogram and the time is measured by second. So the first letter is MKS. So it is MKS system. So totally 3 common systems are here: FBS, CGS and MKS system. Nowadays which one we are using? We are using a SI system of unit. SI system means what? International system. It is a basic of all the things. So it is an international system. So it is more convenient. Why you are using? It is more convenient in practice. For that we are using. And it is a permanent permanent one, and reproducibility do not vary with the time. So you are using SI system here. Okay, what are the advantages? Why you are using this SI system? Advantages of SI system, because the first one, it is a rational system of unit. It use only one unit for one physical quantity. I am taking only physical quantity. One physical quantity means I am using only one. I am taking length means I will use only the meter. That is only a quantity and the unit. So it is a rational system of unit. The next one you are using for the coherent. Second one is coherent system of unit. What is mean by coherent system of units? All the derived unit can be easily obtained from basic and supplementary unit. So it is a coherent system of unit. Now the third one is a metric system. What is mean by metric system? Multiples and submultiples can be expressed in term powers of 10. So it is metric system. Now the next one, some base quantities and the units of the base quantities. Totally how many base quantities I told? 7 base quantities are there. The first one is length. What is the unit of length? The unit of length is meter. The next one, unit of mass, kilogram. Time, unit is second. Electric current, the unit is ampere. Temperature, the unit is Kelvin. Luminous intensity, the unit is mole. Amount of substance, the unit is candela. So totally 7 basic quantities, that is a fundamental quantities. So 7 basic units, fundamental units are here. Now the next one, some definitions are given. Go through that. Okay, basic definitions. Length equal to what? You know, length equal to distance between. Okay, here the new one is a triple point of water. Temperature at which the saturated vapor, pure and melting ice are in equilibrium. What is the value of triple point of temperature of triple point of water in water temperature of water? 273.16 Kelvin. That is the triple point of temperature of water. Now the next one is derived quantities. What is mean by derived quantities? You are deriving from the fundamental quantities, so it is derived quantities. So what is mean by derived unit? You are using for the derived quantities, that is called derived unit. More example is there, but I gave only few example. Area. How you are deriving? I told length multiplied by length. Length is measured with the help of meter. So meter into meter value is equal to square, meter square. So square meter. Same way volume. Volume means what? Length into breadth into height. Meter into meter into meter. So this is meter cube. The next one is velocity. Velocity means what? Displacement divided by time. Displacement is measured in meter. Time is measured in second. So meter per second. The next one is density. Density means what? Mass divided by volume. Mass by kg. Volume by cubic meter. So mass unit, density unit is kg per cubic meter. The next one is force. What is force? Force means mass into acceleration. Unit of mass is kg. Unit of acceleration is ms power minus 2 or meter per square meter. So m kg ms power minus 2. This is the unit of force, or you know the unit of force is Newton. Both are same only. Okay, now what is the relationship between radian, degree and minutes? You know that 1 degree value equal to pi by 180 degree, 180 radian. Okay, pi, what is the value of pi? 3.14. So 1.74 pi into 10 power minus 2 radian. So 1 degree value is equal to this much of radian. Then the next one, 1 arc, 1 single dash. What is mean by 1 single dash in this side? Minutes. So 1 minutes of arc. Okay, so 1 divided by how many minutes? 60 minutes. So 1 divided by 60. So I substitute the value of here 1 degree value divided by 60 here means I am getting the answer 2.908 into 10 power minus 4 radian, or rounding of the figure means 2.91 into 10 power minus 4 radian. Okay, the next one, 1 double dash. What is mean by 1 double dash? 1 arc seconds per arc. Okay, So 1 degree divided by 3600. So I am simplifying, this means the answer is equal to 4.85 into 10 power minus 6 radian.
Now, the next one is how you will measure the value of length. Measurement of length. First we will see the definition. What is the definition of length? The distance between any 2 points in space. Distance between any 2 points. That is called length. What is the SI unit of length? SI unit of length is meter. It is represented by small m. Okay, now how you will measure the value of length? Macrocosm. What is meant by macrocosm? Here both objects and the distance are greater, very large. Then that is macrocosm. Macro, a big one. Then automatically you will learn about the small one. Small one means what you will tell? It is micro. So here both objects and the distance are small sized. You see the structure of the atom. Electron, neutron, proton, all very small in size, and bacteria, these all in small in size. This is called microcosm. Very big one and the small one. So when you are measuring the value of the distances, they are ranging from 10 power minus 5 meter to 10 square meter, means easily you will measure with the help of the direct method. Okay, you are using the meter scale. Meter scale, how you will measure with the help of the meter scale? 10 power minus 3 meter to 1 meter. Till that easily you will measure with the help of the meter scale. You are using Vernier Caliper. It is used to measure the distance from 10 power minus 4 meter. Screw gauge. It is used to measure the distance from 10 power up to 10 power minus 5 meter. So, the atomic and the astronomical distances cannot measure by direct method. One is a greater distance. Atomic is a smaller one. Astronomical distance is a greater one that you can't measure with the help of the direct method. So to measure very small or very large distances, you are using the which method? Indirect method you are using. So how do we measure the value of a small distances? We will see first that. Small distances with the help of the screw gauge. You know this is a diagram for screw gauge. It is used to measure accurately up to how many? The maximum value is equal to 50 mm. Okay, for accurately we will measure the value of the object. The principle, what is the principle used in this side? Magnification of linear motion using the circular motion of the screw. That is the principle of screw gauge. Now, the next instrument which one you are using, that is called Vernier Caliper. You see this is a diagram for Vernier Caliper. So it is used to measure the dimension of the object, diameter of the hole or depth or height. You are measuring with the help of the which one? Vernier Caliper. Both the sides, you know the value of least count. When it is a screw gauge means the least count value is equal to 0.01 mm. Mm means what? Millimeter. When you are measuring the Vernier Caliper means the screw gauge, the least count value is equal to 0.01 centimeter. Screw gauge, the least count value is equal to 0.01 mm. For Vernier Caliper, the least count value is equal to 0.01 centimeter. Okay, now measuring the large distances, what are the methods you are using? The first one is triangulation method, the second one is parallax method, and the third one is radar method. Okay, the first one, triangulation method. With the help of the triangulation method, how you are calculating the height of the object, height of the tree, the height of the building, whatever you are calculating the value of height with the help of the triangulation method. You see the picture. Now AB, what object I am taking? I am taking a tree here. Now this AB is the height. Height is represented by H here. Okay, C the point of observer. Now I am standing here in that particular point C. The distance between the object and the observer value is represented by X. So X is the distance. The angle between both values is equal to the height of the tree or height of the building to the base. That angle is represented by theta. Okay, so now the angle ACB value is equal to ACB value equal to theta. I am calculating the value of tan theta. What is the formula for tan theta? Opposite divided by adjacent. Opposite is AB, adjacent is BC. So H divided by X. Now which one is a question mark to you? Height is a question mark. So H value equal to cross multiply X tan theta. Here you are calculating the value of tan theta value is equal to what? So H value equal to X tan theta. With the help of the TC, we will calculate the value of height of the object is equal to what? Okay, then the next one is parallax method. What is meant by parallax method? Very large distances you are using. Large distances such as the distance of the planet, star from Earth you are calculating. That is measured by with the help of the parallax method. Okay, so the parallax apparent changes in the position of the object that is seen from two different positions. In two different positions you are calculating the value. That is the parallax method. The distance between two positions is called base. That is the base I am taking. Now, the next one is parallax method. What is meant by parallax method? Very large distances. Distance of the planet from the sun or the star from the earth you are measuring is that is called that can be measured by with the help of which method? Parallax method. Now the parallax method side, the apparent changes in the position of the object seen from two different positions. So the distance between two different positions is called what? Bases. Okay, now I am taking a pen. See, I am taking a pen with the two different positions. I am measuring the distance. Okay, now first case, now I am closing my left eye and I am seeing with the help of the right eye. And you know down what is the position in that side. And the second case, I am closing my right eye. Then I am seeing, opening my left eye and I am seeing what is the position of the object or the position of the pen. Automatically there is a shift in the position of the object when it is viewed with the help of the two kids. Keeping one eye closed at that time, that is known as parallax. Okay, so two different positions you are measuring. So that is a parallax method. See, this is a diagram for parallax method side. So now I am taking O is the observer. Here we are studying O is the observer. With the help of first left eye I am seeing. Then with the help of the right eye I am seeing. Now the distance value I am taking that is equal to X. The base, the distance between the two positions left and right, that I am taking, that value is equal to B. Now, angle LOR, this is angle is represented by theta, that is called parallax angle. Okay, so this angle is called what? Parallax angle. Now the base LR, this is a base, so I am taking that is equal to B. Now LO, that value is equal to OR, both the values are equal, the distance, that I am taking, that value is equal to X. So I want to calculate the value of theta equal to what? Theta value equal to, how you will calculate? Opposite, B divided by the adjacent, B divided by X. But which one is unknown to you? X, the distance is unknown to you. So I am keeping X one side. So X value equal to B divided by theta. That gives the value of X is equal to what? The distance value is equal to what? Okay, now the determination of a distance of a moon from Earth. How you will calculate the distance from moon and Earth. You see the diagram? With the help of the parallax method you are calculating. Now I am taking here C. C is the center of the Earth and M is the moon. So the position of the moon, here I am taking the position here is M. And A, B, opposite side, two ends of the earth, surface of the opposite surface of the earth I am taking. Okay, then angle is theta. Theta is a parallax angle, theta here. Now theta value equal to, how you will calculate the value of theta here? I want theta value is equal to, theta equal to what? Opposite divided by the adjacent value. Okay, here I am taking AB is a base and AM. AM and MB both the values are equal. So theta equal to AB divided by AM. Now I am assuming AM and the height value MC both the values are equal means this AM is replaced by MC. So now the formula is theta equal to AB divided by MC. You want to calculate the value of distance only. So keep one side MC value equal to. So move the theta to the denominator side. We will get MC value is equal to AB divided by theta. Now the last one is radar method. What is radar? Radar means radio detection and ranging. Where you are using, it is used to measure accurately the distance of a nearby planet or any object, sun, moon, whatever. You have to calculate accurately the distance means you are using radar.
Students, in this class, you have learned about fundamental quantities, derived quantities, fundamental units and derived units, and you know how to measure the value of length. The smaller one means you are using screw gauge, Vernier Caliper and scale, and you are measuring the larger one means you are using parallax method, triangular method and triangulation method and radar method. Thank you, students.